All right, so we're diving into some early sleep and dream research today. Two studies that really kind of shifted how we think about what happens when we sleep.
Yeah, for sure. These papers are really foundational.
So first up, we've got Azarinsky and Kleitman. Back in 1953, they discovered REM sleep. Before this, we had no clue about this whole stage of sleep, even though it's so tied to dreaming.
It's wild, right? Like now it seems so obvious, but there was a time when we didn't even know REM existed.
I know, right? And then we've got William Dement's research from 1960. He took things a step further and asked, do we even need to dream? What happens if we don't?
Yeah, and the results were pretty unexpected.
So let's start with Azarinsky. He was observing infants sleeping, noticed their rapid eye movements, and thought, maybe this has something to do with dreaming.
It's amazing how these simple observations can lead to huge breakthroughs. So in their study, they decided to monitor adults' eye movements during sleep using electrodes. Then they'd wake people up at different points and ask if they were dreaming.
Sounds very hands-on.
Oh yeah, very much so. And what they found was this strong correlation between periods of rapid eye movement, which they called REM sleep, and vivid dream recall. Basically, if you wake someone up during REM sleep, they're way more likely to remember a dream than if you wake them up during other sleep stages.
So that's how REM sleep was discovered. It's
Yeah.
linked to dreaming.
Yeah.
And this opened up a whole new area of research.
Exactly. And we can't forget that sleep is divided into 4 stages. REM is just one of them.
Yeah,
And it cycles with the other stages throughout the night.
right. It's not like we just stay in REM all night long.
No, each stage plays a role.
Yeah.
But REM is where we see the most vivid dreaming happening, which brings us to Dement's work. He was curious about what happens if we interrupt this crucial REM stage.
So how do you even test that? It sounds kind of ethically tricky.
Well, it started with establishing baseline dream patterns. So participants would sleep normally for a few nights while their brainwaves and eye movements were monitored. Then came the deprivation phase. They'd wake participants up every time they entered REM sleep.
Oh, wow. That sounds pretty disruptive.
The number of awakenings varied, but initially it was something like 7 to 22 times a night. But here's where it gets interesting. As the study progressed, they had to wake people up more and more often.
So their bodies were like fighting to get into REM sleep.
Yeah, exactly. By the last night, some participants were being woken up over 30 times. This showed a clear increase in the drive to enter REM, a pretty strong sign that something important was going on.
Wow, that's fascinating. It really does point to us needing those dreams. But what happened when they were finally allowed to sleep undisturbed?
Well, they experienced what we now call REM rebound. They basically spent a significantly longer time in REM sleep than usual, almost like they were making up for all that lost dream time.
So we've got REM rebound, this increased drive to get into REM sleep during deprivation. It's really starting to look like dreaming isn't just some random brain activity, right?
Yeah, it suggests there's a biological need for dreaming. The question is why? What function is it serving that's so crucial?
That is the question. What's going on in our brains during REM sleep that we seem to crave so much?
Well, there are theories connecting it to memory consolidation, processing emotions, and even personality development. One idea is that during REM, protein synthesis increases in the brain. This could be involved in all those processes.
Protein synthesis. I thought that was more about building muscle, not so much about dreams.
Well, it's involved in tons of bodily processes, including building and repairing tissues. In the brain, it plays a role in creating new connections between neurons.
So could this be the link to memory and learning then?
It's definitely a possibility. Think of REM sleep as a time when your brain takes all those experiences from the day and strengthens the important connections, helping us solidify memories.
Okay, that makes sense. But Dement's study also found that depriving people of REM had some more immediate effects too, right?
Yeah, he observed some interesting behavioral changes even in this early research. Things like increased anxiety, irritability, and trouble concentrating.
So not getting enough REM could actually affect how we function during the day.
It really seems that way, and this was just the beginning. Dement continued this research for decades, but these early findings were groundbreaking.
Okay, so we've got this biological need for REM sleep, potentially tied to all these vital brain functions. And depriving ourselves of it has some noticeable consequences, even in the short term.
Yeah.
But what happens when we add things like alcohol to the mix?
That's a really important point to consider. Alcohol, certain medications, even just having an irregular sleep schedule. All of these things can disrupt REM sleep. And as Dement found, when REM is suppressed, the brain really wants to get back to it.
Right, the whole REM rebound thing. But what's that actually look like when alcohol's involved?
Well, Dement noticed something interesting with one participant who'd had a few drinks before coming into the lab. His REM rebound the next night was much smaller than they expected.
So it's almost like the alcohol kind of balanced out the deprivation effect.
In a way, yes.
Yeah.
But while it might seem like a way to avoid that intense REM rebound, consistently using alcohol or other substances to suppress REM sleep can have some pretty serious consequences.
More serious than just feeling groggy the next morning.
Remember those minor behavioral changes we talked about, like the anxiety, irritability, trouble concentrating? Well, those can become a lot more pronounced with chronic REM suppression. And there's more. Dement's later research actually suggested a potential link between prolonged REM suppression and something called delirium tremens. It's a severe form of alcohol withdrawal.
Delirium tremens. That sounds pretty scary.
It can be. It's actually potentially life-threatening. Involves hallucinations, confusion, even seizures, while the exact cause is still being debated. One theory is that it's triggered by this extreme REM rebound after prolonged suppression. It really highlights just how important REM sleep is for our mental well-being.
So it's not just about feeling rested, it's about keeping our brains functioning the way they should.
Exactly. And while Dement's focused mainly on the consequences of deprivation, later studies building on his work started to explore the potential benefits of getting enough REM.
So there's an upside to all this dreaming.
There seems to be. Some researchers believe that REM might be crucial for things like learning and creativity. Think about how dreams often combine all these seemingly random bits of information from our day.
Right. It's like our brains are trying to make sense of everything, sort through all the chaos.
Exactly. And that process could be key to consolidating memories, strengthening those neural connections, and even coming up with new ideas.
Okay, so maybe those weird dreams aren't so useless after all. More like a nightly brain workout.
Yeah. Think of it as your brain's nightly cleaning crew, tidying up, organizing, and maybe even building something new while they're at it.
That's definitely a better image than delirium tremens. It really puts Oserinsky's discovery into perspective. His observation of eye movements in infants opened the door to all of this research, leading to these insights.
It's amazing how one discovery can have such a huge impact. And the research didn't stop with Dement either. These foundational studies laid the groundwork for countless others. To dig deeper into the mysteries of sleep and dreaming.
So what came after that? Did anyone ever challenge Oserinsky and Kleitman's findings?
Yeah.
You know the whole thing about REM sleep being the only stage where we dream.
There was actually a study back in 2004 that suggested we might actually dream during other sleep phases too, specifically non-REM sleep.
Oh, really? So maybe we're dreaming more often than we even realized.
It's possible. The study found that these non-REM dreams tended to be less vivid and harder to remember, which probably explains why they flew under the radar for so long.
Yeah, that makes sense. If you don't remember it, it's tough to study it. But if we're dreaming during non-REM sleep too, does that change how we think about the purpose of dreaming?
That's a great question. And honestly, one that researchers are still trying to figure out. It definitely adds another layer of complexity to the whole thing.
Speaking of complexity, what about daytime sleep? Does that have any impact on REM sleep?
Another good one. A recent study looked at REM patterns during daytime naps, specifically in people who were sleep deprived. They found some pretty interesting differences compared to nighttime sleep.
Like what? Do we get less REM sleep during naps?
Not necessarily, but the patterns were different. The drive to enter REM sleep wasn't as strong, and the REM rebound effect was smaller.
So maybe our bodies are just wired for nighttime sleep when it comes to REM.
It seems that way. We evolved to be awake during the day and asleep at night, and our REM patterns have likely adapted accordingly.
Well, this has been a truly fascinating deep dive into the world of sleep and dreams. From Oserinsky's simple observation about eye movements to Dement's groundbreaking research on REM deprivation, it's clear that sleep is way more complex and important than we often give it credit for.
I completely agree. These early studies were really the foundation for our understanding of sleep stages, the crucial role of REM sleep, and the potential consequences when we mess with this vital stage.
And it's not just about dodging the negative effects of sleep deprivation. There's more and more research suggesting that REM sleep could be essential for learning memory, creativity, and even our overall mental and physical well-being.
Exactly. So next time you're thinking about pulling an all-nighter or sacrificing sleep, think back to what we've talked about today. Those dreams might be more than just random neurons firing. They could be your brain's way of processing information, solidifying those memories, and getting you ready for the day ahead.
It's incredible to think that all of this is happening while we're seemingly unconscious. Sleep truly is a remarkable and essential part of what makes us human.